Muy buenos días, chicos. Os voy a comentar que por algún motivo no hemos podido dar la clase online, no os habéis podido entrar por algún motivo a la videollamada de Teams. Os explico cómo hacerlo en este video tutorial y os doy la clase. ¿De acuerdo? Entonces, bueno, lo más fácil que vosotros tenéis para poder entrar en Teams sería entrar en el aula virtual. En el aula virtual yo ya os he preparado un enlace para la videollamada, ¿de acuerdo? Hay dos supuestos: que tengáis cuenta de Teams y que no tengáis cuenta de Teams aún por algún motivo. ¿Vale? Bien. Si tenéis cuenta de Teams, habéis de pulsar la tercera opción, abrir aplicación Teams. Si no tenéis aplicación de Teams, debéis de entrar como invitados pulsando aquí donde pone continuar en este explorador. Yo, como si tengo cuenta de Teams, le doy a abrir Teams. ¿Vale? Se abre la aplicación de Teams y me uno a la videollamada. ¿De acuerdo? Ya está, es decir, no es tan difícil. El vídeo no funciona, tiene problemas ahora mismo porque estoy utilizando un capturador de pantallas, ¿de acuerdo? Para enviaros esto, ¿vale? Pero si no, no habría ningún problema, ¿vale? Podríamos entrar y aquí deberíamos de estar todos, ¿de acuerdo? En esta videollamada. Vale, paso a explicaros lo que os hubiera explicado hoy en la clase, ¿de acuerdo? Bien, entonces, en el aula virtual tenéis la planificación de todo lo que vamos a ir haciendo en el curso, ¿vale? Ya lo he modificado, ya están todas las actualizaciones hasta final de curso, ¿vale? Entonces, incluso tenéis las fechas de exámenes. Entonces, mirando en la planificación, veis que para esta semana, la del 11 al 15 de enero, que es en la que estamos, eh, tenéis que hacer dos cosas: completar la versión dinámica en Tecnodoce 18 de la asociación serie, ¿de acuerdo? Y dos, en el aula virtual habéis de entregarme un resumen en cuaderno, ¿vale? En una hoja de cuaderno, hacéis una foto con el móvil y la subís al aula virtual, donde pone aquí, dice, complete a one-page summary about the topic in your notebook. Y que subáis una foto, ¿de acuerdo? Lo subís aquí. Bien, este es el plan para esta semana. ¿De acuerdo? Bien, pues cierro el plan y vamos al lío, ¿vale? Entonces, en Tecno 1218, cambio a inglés, ¿ok? So this one is unit number 2 about electricity. We have already started, but I want to make a brief summary. So for the current week, what I'm expecting from you is to finish the dynamic version of this mini chapter, that is series association of load devices and generators. Question: have you ever seen something like this before? Having 2, 3, 4 different cells connected in a flashlight like this one? I understand that many times, many times. Okay, so I want you to do the dynamic version. The first slide, we devote this one to the series association of generators. This setting is typical, having two or more than two cells connected one after the other. This is what we call series association. So series association is connecting, in this case, generators or power sources one after the other. For connecting generators in series, it is not the same the order of the poles. So we have to connect the positive terminal of one battery to the negative terminal of the next one. Okay? Positive and negative. What happens in this case if we use this way for connecting them in series? The main advantage is that the total voltage is the addition of the individual values. Okay, so the main advantage of connecting batteries in series is that the total voltage is the addition of the individual values. Here you have the formula. Okay, so the total voltage is equal to the addition of the individual values. Question: two generators are connected in series if they are connected to the negative terminal. of both generators. The positive terminal of a generator is connected to the negative terminal of the next one. They are connected to the positive terminal. All the other answers are correct. This one is the correct one. Okay. The total voltage of the assembly in the image is, we have two batteries connected in series, one after the other, and the rule of the poles, okay. So the positive terminal connected to the negative. So the total voltage is the addition, this one, okay. And which of these pairs of generators is connected in series? These ones are connected one after the other, but they are not following the poles rule. This one are following the poles rule. I mean the pole rule when the positive terminal is connected to the negative terminal. This one is also not fulfilling the pole rule. Okay, so B is the right one. In this one, indicate which of the following sets of generators is not connected in series. Which one is not? This one is connected, this one is connected, this one is connected, but this one no. So D is the right answer. The total voltage of several generators in series is multiplication, the same voltage, the average, or the addition. The addition. Okay. Okay. Somewhere we have a mistake. Total voltage is the sum one, the addition. Which of these pairs is connected in series? B. B. This one. Okay. Two generators are connected in series if the positive terminal is connected to the next one, and I think D was not the one. The total voltage is this one. Okay. So this is the main application. The addition having higher power. Okay? Here we have a flat battery. A flat battery in the inside is made up of 3 individual cells of 1.5 volt each. So the total voltage of the flat battery is the addition of the individual values. Also happens the same when we are using solar cells. A solar cell, each one of the individual solar cells is providing 0.5 volts. That is too little. Okay, so for powering a motor, like the one that we have here, we have to connect more than one. Okay, in this case, if we have 4, the addition of the individual values are providing how much? Yes, you're right, 2 volts. So adding these 4 cells, we have 2 volts here. And the image corresponds to solar panel formed by cells connected in parallel. No, they are not connected in parallel. They are connected in series. This one, okay? What flashlight will provide more light? The more light is related with the more power. Well, the more power is related with the more voltage. So this one is the one that has more voltage. So A is this one. Flat battery is formed internally by 3 cylindrical batteries connected in series, 3 cylindrical batteries in parallel, prismatic parallel batteries. No, this one. Good. And the voltage produced by a single solar cell is about 0.5 volt. By increasing the voltage of a bipolar circuit, the power provided is not altered. This one is not true. Is also incorrect. This one is true. None of the other answers is correct. Is not true. The power provided, this one. The power provided is also increased. I don't know where is the mistake. And the image corresponds to this one series. The voltage in a single is about, oh, it's not. The 3 are the same. A is the good one. Batteries in series. By increasing the voltage of a bipolar circuit, the power is also increased. Okay, let's see where is the mistake. This one is okay. It's providing more light. A is the good one. The voltage produced by a single solar cell. All the other answers are correct. Okay. By increasing the voltage applied to a circuit, the power provided is also increased. This one is serious. Okay. And the last. In this case, we are not connecting batteries in series. What we are connecting are load devices, receptors, devices that are going to consume electrical energy. So there is a rule. When we have more than one, in this case, we have the same receptors, one after the other. In this case, we don't need to follow any pole rule. Okay, so it is the same. Connecting this terminal with this one or this one with this one. Okay, so this one is the typical setting. What I told you before, the connecting receptors in series is connecting them one after the other, no matter the pole. So this setting is okay, this one is okay, the four settings are okay. Examples of receivers or load devices in series. Here I have two motors, one motor, a buzzer, and a bulb. Okay. Indicate which of the following pairs of bulbs is connected in series. This one, no, they are in parallel. These two are in series, but here we have a short circuit. These two are in series, but here we have another short. And this one, D, setting D, is a right way for connecting bulbs in series. So D is the right answer. The image shows two motors connected in parallel. No, they are not in parallel. They are two motors connected in series to recharge a battery. We haven't even talked about recharging any battery. Two motors connected in series. Yes, this one. Okay. Two receivers are connected in a series if the cable coming out of a receiver is connected to the input of the other. This one is okay. The inputs are connected, the output are connected, and all the other. No, is the one. Okay. Indicate which of the following pairs of bulbs is not connected in series. This one is not. Okay, so C, B and C are not connected in series. B and C are not connected in series. You have, okay. One typical problem when connecting receivers in series is if one of the receiver fails, the other three fail. Okay, because we have a single path for the current to flow. Okay, the main rule when using different receptors connected in series is that they share voltage. Okay? The flat battery is providing 4.5 volts. 4.5 over 3 is 1.5 each. Okay, so we are sharing voltage. And okay, the last set of questions. The electric current in this picture, is this picture correct? Yes, the electric current will flow even if a bulb is fused. No, this one is not okay. Because if the bulb is fused, we will have no current flow. Yes, if a bulb connected in series blows, the other will shine more brightly. This one is not true. No, a fused bulb continues to shine. No, if a bulb connected in series blows, the other will stop working. This one is the correct answer. What voltage received each one of the bulbs? We said before that the total voltage in this case is shared, so 1.5 and we write the answer. What happens is a receiver connected in a series breaks and the circuit is open. And The other receivers operate with more. This is not true. The other receivers connected in series also stop working. This one is the correct one. The voltage provided by the generator in a circuit. Okay. And the voltage provided by the generator in a circuit that only has receptor in series. Just reaching the receiver is null. It's this one in proportion to the resistance. Very good. Congratulations. Okay, so I want you to do the dynamic version of the mini unit, and I want you to do a summary in paper in your notebook. Okay, you make a picture, you make a photograph with your mobile phone, and you upload the photograph of the summary into the Outlook. Okay, I hope you have understood everything. If you have any question, please leave the question in the forum. See you. Bye bye.